So, welcome back to the next lecture. So, what we have looked so far is that global warming is happening. There are clear evidences of changes because of that global warming which is happening. We have started looking into signs of these changes, and what we have noticed is a clear indication through what is a phenomena called radiative forcing. And when we looked at this radiative forcing, we looked at that carbon dioxide was the gas which was primarily responsible for this radiative forcing, and while some other gases like methane, hydrofluorocarbons, nitrous oxide is what is leading to this radiative forcing. Now, one other debate which kind of keeps happening is that which I mentioned earlier also is that is it just a natural phenomena because of all this which is happening, is that when we look at the sun activities, the sun has been primarily the reason why the climate change has happened in the past. Like if you look at last millions of years, whenever the climate change has happened, it has happened primarily because of the sun activity, right. But if you look at the recent sun activity, it is actually having a negative impact on temperature, and if you had just gone by the sun activity, the temperature should have gone down because the radiation actually has gone down. Sun effective irradiance have actually gone down. Effective irradiance has gone down on the earth's surface because of pollution and maybe some of the sun activities. But at the same time, if you look at the temperature of the earth's surface, it is continuously going up. So, it is actually negative correlation with the sun activity. So, whatever changes is happening of late in the earth atmosphere with respect to increasing of heat cannot be explained by the movement of the sun itself. Like, and when we start looking at all the other natural causes also, the other natural causes also, when they have been plotted, they have kind of been shown as a flat line. So, whatever is happening because of the changes in the current global temperature cannot be explained by the natural causes, not only sun, but by other natural causes also, it cannot be explained. And as I explained earlier, that there are 4 or 5 major parameters like greenhouse gases and aerosols, which are having both positive and negative impact on the earth atmosphere temperature through the radiative forcing phenomena. If you look at it, greenhouse gases has continuously increased of late, aerosol activity has also kind of increased, but at a lesser pace. So, overall observation, if you look at it, has been a positive increase in the climate change, which is primarily can be attributed to greenhouse gases changes only, that greenhouse gases are increasing at atmosphere, which is leading to this change in the temperature or the changes in the temperatures 1850. This change in temperature is primarily it can be seen is coming from the change in the greenhouse gases concentration only, that it is pretty obvious from this graph that it is coming from that thing only, and it cannot be explained by other natural phenomena or by the sun movement also. Now, these are the greenhouse gases which are primarily responsible for this change in the earth global temperature and which is leading to all the other climate kind of changes. Let us understand what are these primarily greenhouse gases which are responsible. So, we have already mentioned carbon dioxide, methane and nitrous oxide, which are primarily the gases which are prime greenhouse gases, and also some fluorinated gases which are there. So, carbon dioxide, what emits carbon dioxide? So, it is primarily the combustion of fossil fuels, coal, oil, natural gas, and we will look into this data more and more, that how they are very much directly correlated with increase in the carbon dioxide concentration, and also by increasing the biomass burning, by industrial chemical process like cement calcification, and also when we are going into soil uptake and we are looking into some of the oceanic activities, some of them are responsible for this increase in the carbon dioxide in the atmosphere, but it is primarily the fossil fuel or the industrial process which has been primarily found responsible for increase of this carbon dioxide in the atmosphere, and we will look into this data more and more as we kind of go along. Methane, it kind of comes in the extraction or the transport of coal, oil and natural gas is where the methane gets emitted, but methane primarily comes from livestock, rice paddies, manure management is from methane is primarily coming out. Organic waste going into landfills and wetlands is again a major source of methane emission, and with all the livestock which are being consumed all over the world, they are one of the major sources of this methane emission. And next one is the forestation, or the not a scientific handling of the forest or agriculture waste is the next biggest case of this methane emission. Then nitrous oxide is primarily because of land use practices, industrial processes, use of fertilizers in our agriculture system, and by some burning of fossil fuel and biomass is also responsible for nitrous oxide, but primarily it is coming from agriculture practices, it is land uses practices and industrial processes are responsible for this nitrous oxide. Fluorinated gases has been primarily because of this industrial application or refrigerants or some semiconductor industry. It is primarily an industrial byproduct through which this fluorinated gases kind of comes out. So, if you look at overall, what is happening is that it is all primarily because of industrialization, as you can directly correlate everything to industrialization. You can directly correlate it to burning of fossil fuel or our eating habits, which is primarily responsible for most of these greenhouse gases getting emitted. And so, you can easily correlate that our industrial work started around 1750s or around 1800s is where the major industrialization kind of started, and that is where the primarily the burning of coal and then subsequently by oil and subsequently followed by gas started. In between we also changed our eating habits a lot. So, that all the lifestyle changes specifically with respect to this industrial era has primarily been responsible for this increase of this greenhouse gas emissions, right. Now, for us to understand that why CO2 and why some greenhouse gases have more potent compared to other greenhouse gases, if you look at the GHG impact, that will be driven by two factors. One is what is the potential of each individual gas to warm up the atmosphere, and second, what is the concentration of that specific gas in the atmosphere. So, these are two factors which will be kind of, if I put it to be x and y, so it will be x into y, which will be responsible for potential greenhouse gas impact. Now, if you then start comparing various greenhouse gases, and if you then take carbon dioxide warming potential to be at a nominal value of 1, all the other gases shows much higher potential of global warming compared to carbon dioxide does. So, methane is 21 to 28 times of this, nitrous oxide is also 300 times, fluorocarbons is about 9,000 times of carbon dioxide in terms of potency. So, if you just go by potency, these gases should have been much more responsible for global warming compared to carbon dioxide. And just for comparison, so when we talk about global warming potential, it is the length of the life in the atmosphere and also the strength of IR absorption, which further goes into science of it. I am not getting into science of it, but just from a global warming potential kind of perspective, one molecule of or 1 pound of methane is equal to 21 pound of carbon dioxide. So, that is a kind of potency which methane has compared to carbon dioxide. So, each emission of methane will be 21 to 28 times more than the carbon dioxide emission, right. But then why carbon dioxide is primarily being talked about. So, again let us looking at the data. So, currently in terms of the radiative efficiency, carbon dioxide is not that potent. If again normalize it to global warming potential of 1 or on a 100-year horizon, and all the other gases seems to have much more potency compared to carbon dioxide, like methane now is 28. So, these calculations sometimes you will see these calculations varying slightly. Do not get fixated by numbers that it is 21 or 28. You might have to go into assumptions of calculations behind these numbers. So, do not get fixated by numbers, try to see that trend and try to follow the trend what we are talking about here. Nitrous oxide, fluorocarbons, again, so all of them have much higher potential compared to carbon dioxide. So, but when we start looking at the concentration of these gases in the atmosphere, that is where things start changing, because if you look at the carbon dioxide on a pp concentration in the atmosphere and you start comparing it with methane, nitrous oxide or halogenated compounds, what you will see is that carbon dioxide is in abundance in atmosphere. It is thousands of times bigger than methane, which is twice or thrice than the nitrous oxide. So, this gas is available in ppm, as I mentioned this number earlier also, that was earlier 300, which is now around 420 ppm. It is available in parts per million. So, every 10 to power 6 molecule of air has one kind of 3 molecules of this carbon dioxide which is available. And while this methane and nitrous oxide and all the halogenated compounds are available in actually ppb level, which is much below compared to carbon dioxide. So, then if you just go back to this equation, so it means while global warming potential of many gases is much higher compared to carbon dioxide, the concentration in the atmosphere of carbon dioxide is so high that it is primarily the gas which dominates the global warming potential of the atmosphere, and that is why you saw the radiative forcing was highest for carbon dioxide compared to any other gas in the atmosphere. Right. So, just looking at the potential again. So, global warming potential just with respect to in terms of potential, if you start comparing on a kind of a visual level, 1 is to 28 to 164 to 273 to 7,000 to 24,000. So, global warming potential is much higher for rest of the other gases, but if you look at the total GHG in terms of the impact on the atmosphere side, it is 74% of the impact is coming just because of carbon dioxide, because just the sheer volume of carbon dioxide, which is almost 1000 times more than methane, any other gas which is available in the atmosphere. So, that is why it starts impacting. This has much more profound impact on overall global warming potential in the atmosphere, right. And so, that is why carbon dioxide is the major gas that we talk about whenever we talk about global warming potential, and we kind of normalizes all our discussions around carbon dioxide, even methane or any other gas also. When we are trying to talk, we always talk in terms of carbon dioxide equivalent terms, because that is the gas which is leading to highest global warming in the atmosphere, right. So, now if you start looking at carbon dioxide, this gas, as we already talked about, has increased drastically over last almost like last 40-50 years, but its increase has been very sharp. I will look into more data, but almost from early 1900s, this graph has all been vertical. I do not know if you remember that graph where I showed you that carbon dioxide almost used to go cyclic earlier, and then suddenly for last 100 years or so, it has shown kind of a vertical jump in terms of its increase. So, carbon dioxide has definitely increased drastically in last century or so. While there is some variation which is seen in carbon dioxide with respect to season, it kind of gets highest in the northern hemisphere springtime, and it decreases throughout as the plant grows, because as the plant starts growing, they start absorbing carbon dioxide. So, as the carbon dioxide is absorbed, the carbon dioxide potential kind of goes down, and during the spring time, when the plants are shedding off their leaves and everything, the carbon dioxide potential kind of goes up drastically. So, while there is some variation here, but if you look at this variation, this is nothing but about 4-5 ppm. But what we are primarily interested in, the line which is kind of an average line onto it, and if you look at it, from that side, the average line is on a continuous increasing trend. While there is seasonal variation always with respect to carbon dioxide, the overall the line is an increasing trend, and which is pretty obvious if you start going back into history more and more. So, now since we have understood that carbon dioxide is the gas which is responsible for this global warming primarily, what we will like to understand is that how does this carbon dioxide cycle actually works. Like, so what is the global carbon cycle, how does it work, and the recent changes in the overall atmospheric system, how it has led to the changes in the global ecosystem of carbon. So, just from a cartoon perspective, and then we will go into science slightly a bit more. So, rock weathering is something which kind of reduces carbon dioxide, because that kind of uptakes the carbon, and that is how you see a lot of graphite formation, lot of other rocks formation, which is primarily some slabs of carbon, or if oil goes, so some of these organic material gets embedded in the earth for a very long enough time and heated long enough, production of oil or gases or something of that sort takes place. Volcano eruption increases carbon emission, because that kind of takes away the carbon from the ground and kind of puts carbon back into atmosphere. Fossil fuel combustion, and we will talk much more about this somewhere, which leads primarily to carbon dioxide emission. Ocean, what we have seen is that primarily absorbs carbon, but that it can also emit carbon in some specific cases. And biosphere and soil, again primarily responsible for carbon kind of absorption, but it can also lead to some emission of carbon when they are specifically with tilling of soil, or with respect to some digging or some specific activities which can lead to the embedded soil carbon to come out, right. So that is what can happen. So, carbon cycle is basically the movement of carbon in form of CO2 in and out of atmosphere. That is what the carbon cycle is all about, right. So, it is basically at few things in the systems are absorbing carbon and few things in the systems are emitting carbon, and the carbon kind of moves through various part of our life. Even human bodies has part of carbon dioxide, atmosphere, rocks, earth crust, petrol, diesel, all are made of carbon cycles. Ocean contains a lot of carbon. So this carbon cycle basically has various sources which absorbs carbon, and so they work as sinks of carbon, and then there are things which kind of emits carbon and kind of releases carbon to the atmosphere. Like when this whole system starts working, that between each reservoir there is an exchange of carbon which is taking place, which could be both slow as well as fast exchange of carbon which can take place, and any change of carbon from one source to another source can lead to kind of exchange of this carbon, can lead to imbalance in the system, or it leads to system where it can lead move from one type of carbon to other type of carbon. And let us look more into this. And but problem starts happening when we start putting this carbon gases or CO2 specifically in the atmosphere. And what we have seen is that as soon as we start putting them in atmosphere, it traps heat and it starts warming the earth. That is what is primarily happening. So when we start looking at the carbon cycle, there are two kind of carbon cycles which are talked about. One is what is called as a fast carbon cycle, or it works in slow cycle times. So it could be in year or decades compared to life is like, so it could be a very short term carbon cycle that it can work. And this is a rapid exchange of carbon within the biosphere. Things which are primarily responsible for us are human beings, for example, or animals, or any living bioorganism is what is responsible for this carbon exchange. As I said, that human body also has a lot of carbon, and other animals of this sort, as this carbon sinks or carbon sources or changes carbon from one form to another form, or oxygen to carbon dioxide. But things which is primarily responsible for this thing is what is plants are primarily responsible. Plants, trees, all those bioorganisms is primarily responsible for this fast cycle through a process called photosynthesis. Like again, phenomena which many of you will know pretty well, but it is a photosynthesis which is primarily responsible for this carbon dioxide fast cycle. Like another thing which is primarily responsible for this cycle is a phenomena called phytoclaton, where phytoclaton absorbs CO2 dissolved in seawater, is primarily absorbed by the seawater, and using the solar energy, this plants and planktons converts the CO2 and moisture into some kind of organic carbon and oxygen, forming the basis of food system. So this is basically a food cycle is primarily driven by this short cycle of carbon dioxide is primarily what it is driven by, and this cycle actually is much higher compared to the slow cycle, and this cycle keeps on going continuously, that it is about 10 to the power 15 to 10 to the power 17 grams of carbon per year, or 1 to 1000 to 100,000 million metric ton of carbon is exchanged through this cycle. And this is primarily the basis of the bioorganism, the system kind of working all around it, right. The primary regulator, and that cycle is going on continuously, and that is how the basis of the life kind of continues. But thing which is responsible for monitoring the climate or regulator of the climate is actually the slow carbon cycle, which is primarily responsible for this. This kind of happens over a very long duration of the time frame. So this has overall a lower potential compared to the fast cycle, which is about 10 to the power 13 to 10 to the power 14 gram of carbon per year, compared to 10 to the power 16 to 10 to the power 17 gram per year of fast cycle. And but what has happened is that human emission has exceeded the potential of the absorption of this specific carbon cycle which is available, and which has led to the long term equilibrium getting disturbed. So this is the long term equilibrium which was being maintained by the slow cycle over the period. So fast cycle is always responsible for running over day to day life, that is what is happening. This slow cycle was responsible for monitoring and keeping the temperature in control, or keeping the climate conditions kind of stable. Now that has got disturbed by this exceeding this human emissions, which has led to a condition where the atmosphere or the slow carbon cycle is no longer able to maintain and absorb that carbon anymore, and which is leading to that carbon, since not getting absorbed by this slow cycle, getting emitted to the atmosphere, and which is leading to then for all the phenomena that we have talked about. And again, I will not go into chemistry and science of it, but just for your understanding, what is happening is that carbon dioxide emission is increasing because of all the human activities, which we will see that what all human activities are responsible for this. And those human activities were primarily maintained or monitored by the slow carbon cycle and the fast carbon cycle in the past. Fast carbon cycle continues its work because that is the basis of the life, that how the life is kind of moving forward currently also. But that slow cycle, which was a regulator, is not able to maintain this higher emission of carbon dioxide anymore in the system. So what has happened is that overall carbon sinks and sources, if we talk about that, forest and soils works as major carbon dioxide sinks, removing carbon dioxide via plant synthesis. Respiration by human beings kind of, or animals or soil microbes, releases carbon dioxide back into the atmosphere. We absorb oxygen and we releases carbon dioxide to the atmosphere. Wildfires are converting biomass carbon into atmospheric carbon dioxide by burning carbon and then forming the equation of like burning along with oxygen and forming atmospheric carbon dioxide. Fuel combustion is the largest source of carbon dioxide source which is available now, with no natural source which is able to compensate for the sink of this, is able to work as a sink for this emission, and is not able to offset it. Fossil fuel actually has come from a very ancient organism which has been buried under the ground for millions and millions of years. Now humans have found a way to extract them, and since humans have been found a way to extract them and they are coming into a very good form of energy, that energy is actually leading to, since humans want to use that energy, and once they are using that energy, the carbon which was trapped inside the buried earth layers for millions of years, that is getting released to atmosphere now on a regular basis. So this ocean exchanges is one of the source which leads to reducing of carbon, and through marine organism, and also it kind of absorbs a lot of carbon. But what has happened is that excess atmospheric carbon has increased ocean uptake. It has led to acidification of carbon, which has disturbed marine life, and also, so overall this carbon cycle which was working in the sink earlier or in a systematic stable manner earlier is now no more a stable source anymore, right. So just looking at the overall current carbon cycle, the sea surface, the sea still remains as the highest source of the carbon. Terrestrial vegetation is the second biggest source of the stored carbon. So this is basically the stored carbon which is there. Sedimentary rocks and everything is the highest source, but the good that they are buried and they are under the ground, and but they are a very slow cycle. They are pathetically slow cycle, so they don't impact the life over 100 or 200 years, but it is other forms of carbon which is impacting. So another big sink of the carbon is emitted to deep water, which is not getting heated also, and also is having a big source of carbon again, but that is not getting impacted by in day-to-day life so much. What is getting impacted by day-to-day life so much is that fossil fuel emission, which looks low in terms of number, but overall the cumulative effect on year basis is what is leading to increase in the surface water carbon emissions. Your terrestrial vegetation is not able to take it up, soil and organic matters are not able to take it up. So overall it is leading to a situation where the carbon cycle is getting disturbed, and it is leading to a issue of this global warming what we have seen earlier. So let us pick up from the next class onwards. So what we have seen primarily is that the carbon cycle is getting disturbed, and it is carbon dioxide which is the gas which is primarily responsible for this change in the global temperature. Now what we will look into further is that what has led to this fast release of the carbon dioxide, and how it has been related to this industrial era and everything. That is something what we will look into next class. Thank you.